All right, this section 4.3 is about proving lines are parallel. Okay, the learning target here is I can prove that two lines are parallel. We're gonna need to use the information we learned from 4.2 about those angle pair relationships and those theorems and postulates to be able to prove that two lines are parallel. Let's get started. Let's first start with what a conditional statement is and what the converse of a conditional statement is. So a conditional statement is just an if-then statement. So for example, if P, then Q. So if P is true, sorry, if P, then Q. So if P is true, then Q has to be true as well, right? And then the converse of a conditional statement is just a matter of flipping the statements. So you start with the last one. So if Q, then P. So that means that if Q is true, then P has to be true as well. Okay. Now, for this sketch right here, these two parallel lines cut by the transversal T, let's write some statements, okay, identifying some angle pairs and some relationships. So we know that line L is parallel to line M. Okay, those two lines are parallel. Angle 3 and angle 6 are supplementary because they form a same side interior angles. Angle 4 and angle 6 are congruent because they're alternate interior angles. Angle 3 and angle 7 are congruent because they are corresponding angles. Now for the next section, uh, I would like for you to pause and try it for a minute or so on your own, okay? So what we're doing in the next section, we're using these statements to write the theorems that we've learned last time and their converses, okay? So I'd recommend you pause it, try a little bit, and then go back to the video. So the first one we're going to fill in here is by the postulate, right? We're looking at the postulate that we learned last time. If line L and line M are parallel, then angle 6 and angle 3 are supplementary, okay? Now we're going to write the converse of that. Remember, we just flip the statements. So we start that with if angle 6 and angle 3 are supplementary, we know that then line L and line M are parallel. Okay? For the next one, we use the theorem that involves angle 4 is congruent to angle 6. So we use that statement. So if line L and line M are parallel, then angle 4 is congruent to angle 6. The converse of that, again, we just flip the statements. We start with if angle 4 is congruent to angle 6, then line L and line M are parallel. And the last one we're going to do is the theorem that involves angle 3 and angle 7 from our statements above. So if line L and line M are parallel, then angle 3 and angle 7 are congruent. Now to write the converse, we just flip the statements. We start with if angle 3 is congruent to angle 7, then line L and line M are parallel. So in order for us to prove that two lines are parallel, we're going to be using the converse of the theorems we learned from the last section. Okay? So those theorems are true, right? The theorems and the postulates are true, and the converse of these theorems are also true. Okay, so if you start off with a transversal, um, cutting two lines, if you have a transversal cutting two lines, and we form those angle relationships that we've learned previously, then we can conclude that the lines are parallel. Okay, so these are the four converses right here that we're going to be talking about. Okay. All right, let's look at it. Let's take a look at example one. Mosaic designer is using quadrilateral shaped colored tiles to make an ornamental design. Each tile is congruent to the one shown here. So each of these tiles right here that he's using for the design matches this one right here with these angles, right? 120 degrees and 60 degrees, okay? Now the designer uses the colored tiles to create the pattern shown here. So this is the pattern he's creating, okay? And we want to use these values of the marked angles to show that the two lines L1 and L2 are parallel. Okay, so the first we start, okay, let's see the measure of angle one. The measure of angle one here is 120. That's the obtuse angle of the tile. And then the measure of angle two is also 120, right? It's also the obtuse angle. So the relationship between the two angles is that they are congruent and they're corresponding angles, right? They're corresponding congruent angles, okay? And the conclusion that we can make here is that line one is parallel to line two by the converse of the corresponding angles theorem. All right, now let's see how we can use angle pair relationships to verify that lines are parallel. So example two, use the given angle relationships to decide whether the lines are parallel. Explain your reasoning. So now we're starting with the fact that angle 3 and angle 5 are congruent, right? We're told that those two angles are congruent, angle 3 and angle 5, okay? And we want to show that line L is parallel to line L. Okay. So the way to do this, there's two steps. The first step, you identify the relationship between the two angles. So we know that angle 3 and angle 5, they are congruent because they are alternate interior angles. Okay, so that's the relationship. They're alternate interior angles. Then the step two, uh, are the lines parallel? Explain. Now we have to say why we can conclude that the lines are parallel. Well, yes, line L is parallel to line LM by the converse of the alternate interior angles theorem. Okay, that it says that if the angles are alternate interior angles, it means that the lines are going to be parallel. Okay. For the next one, we're looking at angle 4 and angle 8. So we know that angle 4 is x plus 20, angle 8 is 2x plus 5, and x is 15. So again, let's compare the angles and find out what's their relationship. So angle 4 and angle 8, okay, angle 4 and angle 8 are corresponding angles, right? We know the corresponding angles are congruent, okay? So we start substituting and figuring out what the measures of each angles are. So angle 4 is x plus 20. We substitute x with 15, so it's 15 plus 20, which equals 35 degrees. So that means that angle 4 measures 35 degrees. Angle 8 is 2x plus 5, so we substitute 15 for x. So we get 2 times 15 plus 5, so that's 30 plus 5, and that's 35 degrees. So angle 8 measures 35 degrees, okay? So angle 4 and angle 8 are corresponding angles. Because they have the same measurement, right? We know that they're corresponding angles, okay? Now, step two, are the lines parallel? Yes, they are parallel. L is parallel to M by the converse of the corresponding angles theorem, okay? It says that if two angles are corresponding angles, that means that the lines are going to be